On Tomorrow's World today, we explore the cutting-edge advances that are shaping 4 different worlds. The world of inspiration, where the wonders of the natural world amaze and inspire us. The world of creation, where ideas come to life from traditional arts. The world of innovation, where ideas and inventions move us all forward. The world of production, where innovations are mass-produced to improve our lives. From Inventionland World Headquarters, here's your host, George Davison.
Hi everybody, I'm George Davison. When you think of steel, you might imagine thick, heavy sheets of metal. But when it comes to electric vehicles, you have to go light. Every extra pound means less range and lower efficiency. So what's the solution? Thinner steel. That's right, there's now steel that it's like paper thin. And it's been engineered specifically for electric vehicles. By using the thinner steel, automakers can reduce the vehicle's weight without having to sacrifice strength or durability. This paper-thin steel, it's made with the latest technology, and it's designed to meet the production needs of this new era of transportation. In fact, by 2030, more than half of all cars sold are expected to be EVs. So I'm gonna send Greg to the world of production to explore how one company is changing the steel production process to make it more sustainable and environmentally friendly.
In 1881, Andrew Carnegie built the first steel mill in the United States, which would eventually become U.S. Steel in 1901. And for many years, it was the largest mill in the world and the most productive of all the steelworks in the Mon Valley. This is still a U.S. Steel site, but now it is the U.S. Steel Research and Technology Center. We're going to head inside, talk to David Burritt, the CEO of U.S. Steel, to take an in-depth look at steel production in tomorrow's world. Hey, Dave, great to meet you.
Great to meet you too, Greg.
As we look at this library, Dave, I feel like this is the history of steel making in the United States, but this Research and Technology Center is all about the future, and I cannot wait to see what you do here.
Safety first at U.S. Steel, and that means hard hat and the rest of the PPE. So let's go. Follow me.
All right. Dave, tell me about the process we're about to see.
Well, this is an A6 continuous galvanizing simulator, one of the kind, and it's used to help power the energy transition of the future. Greg, I need you to meet Alexis and Matt.
Nice to meet you guys. Alexis, tell me about this amazing machine behind us.
So there are a couple AFIC simulators in the world, but our specific simulator was customized for U.S. Steel to help innovate for all of our customers.
Excellent. Well, Matt, why is that important?
So one of the most important types of steel that we develop are the advanced high-strength steels for the automotive industry. The A6 allows us to simulate the heat treatment and coating conditions of any of our finishing lines, including the ones currently being built in Arkansas.
Greg, we need to get you to Arkansas at Big River Steel. Ask for Dan Brown. He's got a full-blown tour for you.
Excellent. Well, I made it to Arkansas, and I'm on the banks of the Mississippi River. It's safe to say that our country might not be what it is today without the mighty Mississippi. There have been so many industries that have utilized this river, it'd be difficult to count. One of the main reasons being that there's no better way to move large amounts of steel than a barge on the river. Now, the river's got a deep history, but it's also got a really bright future, especially when it comes to electric vehicles. There are hundreds of pounds of steel in an electric vehicle. Now, in order to meet that demand in a sustainable way, auto manufacturers are turning to recycled steel. And this plant and all of the new facilities built around it are specifically for that purpose. Turn all of this into recycled steel. I'm at the U.S. Steel Big River Steel facility in Osceola, Arkansas. I'm going to meet with Dan Brown. He is the Senior Vice President of Advanced Technology Steelmaking for U.S. Steel and the Chief Operating Officer of Big River Steel. We're going to talk about all of the new and innovative technologies that are being utilized to get recycled steel into the electric vehicles that you'll drive in tomorrow's world. Hey, Dan.
Hi, Greg.
Good to see you.
Good to see you, too.
Wow, man, I was just out at the scrapyard, millions of tons of metal, and it's all going to end up here.
Absolutely. 100% recycled scrap. That scrap gets charged into the EAF to feed this beast.
Well, I want to see this all happen.
Absolutely. Grab your safety gear. Let's go.
Okay, let's go. Wow, Dan, so this is feeding the beast.
This is feeding the beast. So all the scrap we saw dumped outside into the charge bucket, we charge that a little over 180 tons, put it in the top of the EAF furnace, and make a heat. Our tap-to-tap times are generally 36 minutes.
Wow, so it only takes that long to melt this whole thing, and I find it hard to believe that this is electrical energy, but that stands for electrical arc furnace.
Electrical arc furnace. We use 100% recycled scrap to arc on these heats, electricity, pure DC energy to melt these heats to tap into a steel ladle at the bottom of the furnace and ship for further processing, either to secondary metallurgy or our RH degasser.
Okay, so this vat of molten metal goes to the RH gasser, you said? Tell me about that.
The RH degasser is an interesting story. Big River Steel was the first company to put an RH degasser into a mini mill. It gives us the ability to make automotive steels, high-grade electrical steels, and non-grade oriented steels for electrical vehicles.
Well, I'd love to get a look at that.
Let's go.
So Dan, what makes the degassing process so important to what you do here?
As I mentioned before, we were the first steel company to put an RH degasser within the mini mill steel industry segment. This vacuum degasser gives us the ability to serve customers and markets that no one could ever serve before. The automotive market, non-grain oriented steel, and high-tech electrical steels.
Okay, well, how does the process actually work?
Very interesting process. Behind you is a degasser vessel. At the bottom of that is what we refer to as snorkels, an up leg and a down leg. There's a series of swears for argon gas in the up leg. You actually change the density of steel, lift the liquid steel up, back to the down leg, gravity takes it down, and it's a recirculating process. You actually recirculate the chemistry and homogenize that steel every 2 minutes.
Wow, so what actually happens? It actually just extracts the gas from it?
Interesting process. You get lower carbon levels, lower hydrogen levels, and lower nitrogen levels out of this process.
All right, well, I know we've still got some steps to go, but it feels like we're getting really close to seeing slabs of metal.
Next stop, we'll be taking that liquid molten steel, the ladle, and forming it into a solid transfer bar. Let's go.
Oh, Dan, it looks like we're counting down to something here.
So now we're taking that liquid steel ladle and we're casting that through our casting machine into a solid transfer bar. This machine's speed right now is running roughly at 170 inches per minute, and at approximately 20 inches, we'll be cutting that to a customer specification down on our crop shear.
Okay, let's take a look at this now. So this is actually the molten metal coming out of the ladle.
That's correct. That steel ladle that's molten liquid is being poured out of the bottom into a mold. That mold is cooled with vac water sprays. It actually makes a shell around that transfer bar, cools it from the outside in into a solid state that you have coming down here.
So now as this cools down, it's actually cool enough now to maintain its integrity through the roller.
That's correct. It's formed. You have good shape. The thickness of the bar is a little over 2.5 inches. It'll get cropped to customer specification, perfectly flat, and sent on through this tunnel furnace through our hot rolling mill.
3 football fields later, and this is going to look like what your customer wanted to look like.
That's correct. It'll go through 1,000 feet down to our hot rolling mill and get rolled into a coil.
All right, let's go see what the end looks like.
Let's go. You remember that transfer bar that was 2.5 inches thick that we sent through the furnace that's 1,000 feet long to continue heating?
Right, so it's gotten here, but 2.5 inches thick is not what your customer's usually looking for. How do you reduce that down to their specifications?
Now it enters our hot rolling process. So that transfer bar goes through a series of stands, rolled out, and then sent down a runout table and hit with large amounts of water. We get the mechanical properties out of it, customer width, specification, correct gauge, and that coil at the end of the line will either be sold out into the commercial market or sent downstream to cold roll processing.
So at that point, it's ready to ship.
That's correct.
Let's check that out. So this is the beginning of the rolling and reducing process. Are these rollers the same rollers that are in the machines?
That's correct. The rolls you see right here are the actual work rolls that are in the stands right now. There's 6 stands. Each stand reduces that transfer bar thinner and thinner till you get out of the last stand. Once you exit X6, you're at the exact thickness for customer specification. You send it to the runout table, hit it with water for mechanical properties, and you have a final product on the coiler for the customer.
These rollers have to be really precise. You're looking for a near perfect piece of metal.
The parameters on the work rolls and the grinding, very, very strict to make sure you get the customer specifications.
Okay.
After the steel exits our last stand, It gets x-rayed for the proper customer thickness, goes through our run-out table, gets blasted with high-pressure water for mechanical properties.
So by mechanical properties, you mean either the hardness or the softness of the metal, and you determine that by how quickly you cool it.
Whatever the customer application is, we make that on the run-out table into the coiler.
Okay. So Dan, I mean, you can still really feel the heat coming off of these coils. This can't be the end of the line.
You remember that coil just 2 hours ago was part of a liquid steel ladle, taken through casting, taken through rolling, very critical, precise processes. This coiling temperature is very important too for final properties. We'll get that coiled up, either sent out for customer shipment or further downstream within our own process.
Let's head downstream.
So some of the hot roll coils are going to go directly to customers. Others go downstream in our facility through our pickle line tandem mill. We refer to it as our PLTCM. The pickling part of the process, you take the hot roll coils, weld them together to make a continuous operation. After that, it's sent directly into the cold mill behind us for cold reduction.
Okay, well, let's take a look at that.
Let's go. So after our coils are run through the pickling part of this line, this is one continuous line, taken directly from the pickle line through the cold reduction, cold rolling process. Similar to the hot rolling process, 5 stands, take a little bit more reduction with each stand. We get down to the final thickness and gauge for the customer specification. These coils are taken off the mandrel. Some of these coils are shipped out for its final product. Other coils are sent to our galvanized line next door. Let me take you there.
This steel isn't specifically for EVs, but it is used in the automotive industry and for some of your other customers as well.
That's correct. We just got done cold reducing our coil. Now we put them through a furnace for mechanical properties, run them through a zinc bath, put a slight layer of zinc coating on the material, and we use that to supply automotive and construction customers.
All right, well, I want to see this galvanizing process, and I guess it's a hot process. We're all suited up, so let's go.
Follow me. So these 2 coils are sheared here, the tail end of the previous coil, the front end of the next coil, sheared, welded together within a minute, and sent down to the process. We have to run this line continuously. It has to run 24/7. To our right are the zinc ingots that we add to our zinc pot to get the right chemistry for the molten zinc that we put on the steel coils to get to the right customer specification.
Wow, Dan, that looks like a mirror, but I would imagine if you shattered that thing, you'd catch a few more than 7 years of bad luck.
So the steel's taken through a furnace, heated up to the proper temperature, annealed to get the right mechanical properties for our customers. And now we bring it down to a molten zinc bath that's currently at 462 degrees Celsius.
Wow, so that's well over 800 degrees Fahrenheit.
Well over 800 degrees Fahrenheit, and then taken up through a series of air dryers to the top of the roof of this production line.
How far does it travel up as it dries?
184 feet.
So at that point, it's dry enough to be coiled back up, put on the rails, and sent back out.
Absolutely. It'll be taken out to a rail car, put into the rail car, and shipped to a customer. Let's go see it.
Wow, Dan, this coil looks very different than the way it started out.
Yes, this coil is a final product. This has been galvanized, coated, packaged up, banded, and now this is ready for shipment, ID'd for our final customer.
Dan, we've learned a lot about the different metals that you make for various markets, but right now, I want to learn more about Big River Steel, US Steel, and electric vehicles.
So you've seen the whole process so far, 100% recycled scrap, melted, casted, rolled up to this point. And this behind us is a world-class $450 million investment in non-grain-oriented electrical steels. Non-grain-oriented electrical steel for the electrical vehicle market and the future of the United States.
Excellent. Can we go inside?
Let's go.
All right, now I get it. This is what $450 million looks like.
Behind us is our non-grain-oriented anneal coating line. This line is part of the non-grain-oriented steel electrical project. This line creates the mechanical properties and magnetic properties for our electrical steels.
This looks a lot like some of the processes that we've already seen. How much of this is evolution and how much of it is brand new?
It's a combination of technologies, almost like a giant continuous annealing line and on top of it, making magnetic properties for world-class non-grain-oriented electrical steel for the electrical vehicle market.
Okay, well, how big is this building? It's massive.
This building is massive. This building is 3/10 of a mile long.
Wow, you want to take a walk?
Let's go.
You know, Dan, the steel industry has been around for well over 100 years, but it's pretty clear you're not resting on those laurels. It looks as though U.S. Steel is all about innovation.
A lot of people view steel as just a commodity. It's not, Greg. Steel is highly technical and highly innovative. We spent a lot of time on research, development, and innovation within our company. This line in back of us and the whole NGO project is a perfect example of that.
As massive as it all is, I know that this is just the tip of the iceberg of what you're developing here.
That's correct. And I'd like to show you our second part of our close to $4 billion of investments.
Well, Dan, you got me intrigued. You mentioned new products coming out of this area, and you've got another massive structure here. What are you building, and what are you going to do with it?
So you remember our continuous galvanized line number 1 that we went through. This is CGL2. We're going past the furnace structure right now. This line uses a zinc and aluminum coating as opposed to just a zinc coating. Guaranteed for 60 years, weather and corrosion resistant, very popular with the roofing and the appliance industry and market.
Well, Dan, tell me about your vision here, because right now this just looks like a big hole.
It is a big hole, but it is the future site for our zinc aluminum pot for CGL2. You remember when we toured continuous galvanized line number 1, when you referred to the steel strip as a mirror? This is the area where we'll coat with both the zinc and aluminum to the strip and get into the products that we discussed earlier.
Okay, well, how long will it take you to get this up and running?
The construction and engineering of this will be finalized and this line up and running within a year from now.
Wow, that's amazing. Well, I know there's lots more to see, so are we going to be able to check that out?
We absolutely will. I saved the best for last, but we're going to need my truck to get there.
Let's take a ride.
Let's go.
Dan, there's a lot of construction going on here. What do you think, another 3-4 years before you start producing out of this?
No, this will be operational in less than a year. BRS was one of the best startups in the history of the steel industry in North America. Very aggressive timeline, very challenging. That engineering and construction group that built BRS is actually building BR2. We've managed to keep that whole group together. We are on schedule and on budget at this point in time.
When you have a great team, why break them up, right? Okay, so Dan, tell me about the buildings that are right in front of us.
So this building is one of our autonomous coil yards. So this is high-tech automation, moves coils, stores coils, and ships coils by rail or truck without human interaction.
Wow. So what are the other buildings that are under construction right now?
So to the left is the finishing areas that we talked about before. That's the value-added lines attached to the pickle and tandem mill process. And then the back is going to be where our hot end goes, the melt shop and our endless strip processing, our ESP technology for casting and rolling.
Now, in the past, most of this stuff would have been spread out over several areas or maybe even a couple of different towns, but you're doing everything right here.
That's correct. We act as our own general contractor, so you'll see buildings in different states with concrete pours, with girders and beams being put up, with skins putting on the outside. We actually get the buildings up, and some of these buildings we're actually storing some of our equipment in already, so it's under shelter.
Wow, well, this has been amazing. Dan, thank you so much. I can't wait to see how this all develops, but in the meantime, I've got to get back to Invention Land. How about giving me a ride to the gate?
Yeah.
Hi, Dave. Welcome to Invention Land.
Great to be here, George. Thanks for having me.
I couldn't wait for you to get here because I'd like to hear a little more about the future of steel.
Well, I'm holding the future of steel. The future of steel is now. Thin as a piece of paper, feel that. Mined, melted, and made in the good old USA.
It's light, too. How strong?
Durable as that heavy piece of steel you just picked up.
That's really cool. I'm hearing some great things. Greg was talking about everything you're doing down there, and he was saying there's a $3 billion plant being built right now.
You know, you think about U.S. Steel, there's a lot of firsts associated with U.S. Steel. We've been around for 122 years. Now, we're the first U.S. steel company to set a net zero emissions target for 2050. With Big River, we're the first ones to have a LEED certified mill in the United States. And now, Responsible Steel has actually certified the mill at Big River Steel.
So you've made a big investment in the future.
Yeah, think about this steel. This goes in the electric motors. So you stamp it, you stack it, and it's so lightweight that it lets the motors go further. That is further between charges so that you can actually take your vehicle on that long vacation.
With a new kind of steel that's lighter, stronger.
Only company to make it in the United States that's 75 to 80% less GHG emissions.
GHG, I'm sorry?
Greenhouse gas emissions. We have to make sure that we're doing our part to reduce that.
Well, I can't thank you enough for coming into Invention Land.
It's great to be here.
All right, take care now.